Welcome to the video on sustainability, where we will look at the concept of carbon footprint. Now, the supply chains involve the flow of materials and services right from the raw material sourcing until it reaches the final customer. So as you must have seen in my previous videos, basically the supply chain starts right from the raw material sourcing, then it goes to manufacturing, goes through warehouse, goes to the retail, and to the final customer. And at each stage of the supply chain, there is energy consumption, which in turn can have negative impact on the environment. In terms of, let's say, there are emissions from transportation, there are energy usages for electricity in the manufacturing facility, and so on. Now, for a firm, the way to measure the total amount of greenhouse gases produced to support their operations is through their carbon footprint. So, like we mentioned, at every step there is energy consumption, which may eventually end up with emission of greenhouse gases, and this is measured through the term called carbon footprint. Now, the carbon footprint is expressed in terms of carbon dioxide equivalent, or CO2e. So in this video we will further deep dive into this concept called carbon dioxide equivalent. Now, as we saw earlier, carbon dioxide is the most common greenhouse gas. However, there are other greenhouse gases like nitrous oxide, methane, water vapor, etc. Now, when you compare molecule for molecule, many of these other gases cause more warming than carbon dioxide. For example, methane causes 120 times more warming the moment it reaches the atmosphere. However, methane does not stay around as long as carbon dioxide. So, the impact of these gases is a factor of the ability to trap heat. So that is one, that how much heating is the other gas causing, as well as staying around for long. How long are these gases staying in the atmosphere? Since this differs for different greenhouse gases, in order to define a standard, their impact is calculated in terms of carbon dioxide equivalents. So these other greenhouse gases vary in terms of how much heat they trap and how long they stay in the atmosphere. And to standardize this, the carbon dioxide equivalent has been created. So basically, CO2 equivalent, or CO2e, is a unit of measurement that is used to standardize the climate effects of various greenhouse gases. So it is used to standardize the climate effect of various greenhouse gases. So now let's look at this in little more detail, and let's see how to calculate the carbon dioxide equivalent. Now, one of the terms we need to understand is called global warming potential, or GWP. So the GWP, or global warming potential, of a greenhouse gas indicates the amount of warming a gas can cause over a given period of time, usually 100 years. So like we noticed earlier, there are two factors for each of the greenhouse gases. One is the amount of warming, and second was the time period for which it stays in the atmosphere. Now, GWP has made this time period as 100 years. So around 100 years, if we take each of the gas, how much is the amount of warming that a gas can cause? So we are moving towards standardization. So GWP is an index where CO2 is the baseline having the index value of 1, and the GWP of all other gases is the number of times more warming they cause compared to CO2. So now, based on this parameter, that is over a period of 100 years, how much warming can a gas cause, CO2 has been made as the baseline on the index and given a value of 1. And all other gases, based on the relative value, are then noted. So for example, the GWP or global warming potential of carbon dioxide is 1, methane is 25, nitrous oxide is 298. So what does this mean? So if methane's GWP is 25, what it means is 1 kg of methane causes 25 times more warming over a 100-year period compared to 1 kg of CO2. So if the quantity is same, that is 1 kg, so 1 kg of methane and 1 kg of CO2, basically what this is saying is that if the GWP of methane is 25, that means 1 kg of methane causes 25 times more warming than 1 kg of CO2. Now, as described earlier, the carbon dioxide equivalent signifies the amount of CO2 which would have the equivalent global warming impact for any quantity and type of greenhouse gas. Now, a particular quantity of greenhouse gas can be expressed as carbon dioxide equivalent by multiplying the amount of greenhouse gas by its global warming potential. Now, for example, if 1 kg of methane is emitted, this can be expressed as 1 kg multiplied by 25. This 25 is nothing but the global warming potential for methane. And this then becomes 25 kgs of carbon dioxide equivalent. So similarly, if it was 2 kgs of methane, so 2 multiplied by 25, that is 50 kgs of carbon dioxide equivalent. And if it was 1 kg of nitrous oxide, then it would have been 298 kgs of carbon dioxide equivalent. So using the global warming potential and the amount of gases emitted, you can easily calculate the carbon dioxide equivalent of the emission. Now, nowadays there are multiple ways to calculate the carbon footprint. Even a common man can calculate their own carbon footprint. There are numerous websites. One of them is www.carbonfootprint.com, where you can calculate your own carbon footprint. And there are calculators which take a lot of parameters like how much energy are you using in the home, what are the public and personal transport that you use, how much aeroplane flights do you take, what are the recycling methods that you use, etc. So this is all about the carbon footprint and how it can be measured and why it is important to measure it. Now let's look at the classification of the carbon footprint measurement. Now, one of the most important aspects in measuring the carbon footprint is to determine where is it coming from. So an organization can have multiple aspects of its functioning. Now, when you're measuring the carbon footprint, we first need to determine where is the carbon getting generated from. This will help you focus your efforts in areas where the maximum benefits can be gained. So there could be different areas, right, within an organization, and depending on the type of organization. So we need to look at the different sites, the facilities, the different activities being performed in an organization, the products that are being produced, etc. Now, the carbon footprint measurement can be classified into three scopes. Scope 1 is the direct emission coming from your company's core activities. For example, emissions coming out of direct production, or it could be consumption of fuel on site via boilers, etc. So this scope 1 is basically your direct emissions coming from your core activities. So if you are in the business of production, then within production, in order to produce your products, you may be having emissions coming out. Similarly, if you're using boilers as part of your production facility, the consumption of fuel for the boilers could be a source of emissions. Now let's look at scope 2. So scope 2 is the indirect energy related emissions of your business. So this is the direct emissions, this is your indirect emissions. This includes all the emissions generated from energy consumption in the form of electricity, steam, heating, cooling, etc. So basically you are using energy for your business to run your business, but it is in the form of consumption of electricity or steam or heating in, let's say, in the winter times, or cooling in the summer times. So all these activities generate emissions which are kind of indirect for your business. So these form the scope 2. Now scope 3. So these are also indirect emissions, but these are upstream or downstream of your activities. So scope 2 was basically directly in your production facility. You are using, let's say, electricity or heating, cooling, etc. Now these scope 3 are the upstream and downstream activities. For example, if you have raw material being delivered by truck, so the truck is generating emissions, and this can be classified as scope 3. Similarly, if your employees drive to the office and generate emissions, then it falls in scope 3 category. So this is the standard which is followed for classification of the carbon footprint of an organization.